Today, aviation emits around 3% of CO2 emissions, but its impact on the climate is even greater because of where those emissions are. ZeroAvia is solving the climate emission problem caused by aviation. We're developing engines that run on hydrogen to generate electricity and power aircraft without emissions. I'm James McMicking, the Chief Strategy Officer at ZeroAvia. We're at ZeroAvia's UK R&D facility in the Cotswolds, and we're integrating these hydrogen electric engines into aircraft in order to test them up in the air. This is where we're developing the future of aviation propulsion technology using hydrogen electric engines. It begins with assembling the fuel cell system. We then add to that the electric engines. So these are the power electronics that take the electricity from the fuel cell system and turn that into a current that can be controlled to run a motor. We do the fuel cell development and assembly here in the hangar. This plane is our Dornier 228 testbed aircraft. So it's been retrofitted with a hydrogen electric engine. So if you follow me down the left-hand side here, there's cables that run in to the fuselage, and you can see a number of black boxes here, which we call open frame fuel cell systems. And this is where the electricity is being generated by the hydrogen through the fuel cell stack. This is a test bed that we can use to validate and test technology. And then further down the fuselage is the hydrogen fuel tank. On the far side, we've got some ducting that's bringing in air from the outside, pushing it through a radiator, and that's being used to keep our fuel cell systems at the right temperature. That's a Cessna Caravan. That engine is in development and will be the first certified engine. We're going to take a look at some of our test facilities here and hydrogen infrastructure. So this is really where the magic is happening. We're now standing in our hydrogen lab, and this facility is for testing our fuel cell systems primarily. This is how we learn and feed back our learning into the design process. And if you follow me into this room here, you'll see what we call our open frame arrangement. So this is where we've got all of the different components and key parts of the system laid out in an open format. So this is not clearly how it would go into the aircraft, but what this allows us to do is switch out components, repeat the testing, and learn from the engines and the technology that we're putting together here. So if you look under here, you've got two silver boxes, and those are the fuel cells themselves. So inside there is where the reaction is taking place to turn hydrogen and oxygen into water and electricity. So here we have our flight test operations, and this is James Yap. Hi James, our Head of Flight Test Engineering.
So flight test engineering here at ZeroAvia fulfills a number of duties, but the main one is to help look after the safe conduct of test flights on the aircraft. And principally, recently we've been looking after our hydrogen Dornier, making sure the 13 flights we've conducted so far have all gone safe and sound. We'll go inside and have a look. We do all sorts of things, from just writing the test cards to planning what we think the performance is going to be like, and then helping them with the safety work. So this is our map of the airspace for southern half of the UK. We're here at Kemble. At the moment we're doing some workup training, and our hydrogen aircraft stays within a 5-mile radius of Kemble. That's about to be increased to 10 miles when we do the next test. Following that, we're able to do our A to B flight, which is moving the aircraft from Kemble down to Boscombe Down, which is an MOD site just here.
At the moment, ZeroAvia is going through a certification process with two regulators, the CAA in the UK and the FAA in the US. And we're certifying the electric propulsion system with the FAA and the whole engine with the CAA. Our first commercial product will be 2025. In 2027, 2028, we expect to be able to power a larger regional turboprop-sized aircraft, and then late this decade into the 2030s, we'll start to break into the jet aircraft space. Hydrogen is expensive today, and that's because there isn't an industry at scale in the short term. The industry does think the costs for the passenger are going to increase as we make that transition. We also anticipate being able to deliver some economic advantages and may actually contribute to a reduction in the cost of travelling in the long term. So that might allow people to travel more, but do so without climate impact.
Sponsored by Petronas.